Hi, this is a recorded lecture for the IB DP Design Technology Ergonomics A1.1 Design in Theory, and we're going to be looking at anthropometrics in this video. This is part 2 of this lecture. Our inquiry focus is how do ergonomic considerations influence the design of a product? And we're going to be focusing in this lecture on anthropometrics, and this is the aspect of ergonomics that deals with body measurements. Anthropometrics is from the Greek word anthropos, meaning man, and metron, meaning measure, and anthropometry refers to the measurement of human individuals. It is the aspect of ergonomics that deals with body measurements, particularly in the areas of size, strength, and capacity. We're going to be gathering a couple of different types of data when we're doing these measurements, because remember that metrics means measurement. So we're going to be gathering static data, and this is the human body measurements when the subject is still. This refers to measurements taken while the subject is in a fixed or standard position. So for instance, arm length or overhead reach. And this is from the Greek statikos, meaning to stand. And static, we see it in a lot of ways. There's static electricity, which is electricity that doesn't flow from one place to another. You might think of the word station, which has the same root word as static. A station doesn't move, kind of what we use the word static for in English. It means it doesn't move. The other type of data that we would be recording is something called dynamic data, and this is from the Greek dynamikos, meaning power. Dynamic data is human body measurements taken when the subject is in motion. And you can see in this example, we're looking at a shoulder rotation. So the shoulder of this individual would be rotating from the A point to the B point, and that would be dynamic data. When we have this data, we need to understand that people come in all shapes and sizes. And so we need to think about the percentiles that they fall into. And this is a definition that means a term that describes how a data point compares to all the data in that set divided into 100 equal parts. From the IB, the concept of percentiles is vital for selecting appropriate anthropometric data to ensure a product accommodates the majority of the user population. You should be able to identify when the 5th or 95th percentile, representing the smaller or largest user, the 50th percentile, or the 5th through 95th percentiles, encompassing a broad range of users, are most appropriate for a given design scenario, demonstrating an understanding of the design for user diversity. And right here, this is a percentile chart. So this is the girl's height over age. Design considerations, and we'll go over these in a little more detail. Students must explain the importance of specific ergonomic considerations in design. These include understanding workspace envelopes. We'll talk about those. And this is the three-dimensional space in which a user operates, reach, clearance, adjustability, and the range of sizes. All these factors must be considered in relation to percentiles when designing products. A little more from the IB. To effectively accommodate a wide spectrum of users, designers can strategically implement adjustability or produce products in a range of sizes. Students are required to explain the rationale behind these design choices and to identify existing products that exemplify these strategies, thereby connecting theoretical concepts to real-world application. And I'll show you some examples of all of these in just a minute. Let's talk about percentile range. So this is the upper and lower limits that a proportion of the population with a dimension at or less a given value. For a given demographic, this would be gender, age, and race, the 50th percentile is the median. We find that percentiles fall in this nice bell curve, right, where your 5th percentile's here, your 95th percentile's here, your 50th percentile's here. We'll find that a population will generally fall into these bell curves like this. Some factors affecting anthropometric data are age. So for instance, children are smaller. You can see that this picture right here is showing a picture of a child's head. And if you're measuring a child's head, we would assume that they would be smaller than, say, an adult's head. We might look at the elderly, so they may have reduced flexibility, strength, or they've lost some height. And some examples include school desks and chairs, or higher seats and armrests for the elderly. So if we're talking about gender, there's a difference in average body dimensions for men and women. And when we talk about this, we are talking about an average here. We're not talking about specifics. So there are some very tall women, but on average, men are taller than women on average. And so we would be looking at like height, limb length, hand size, grip strength, those sort of things. And there's examples like tools designed for both male and female users. We might look at ethnicity or regional differences, so variations in body proportions due to genetics and environment. So this could be average height, impacting door frames, vehicle seating, facial structure. This might influence glasses or masks. We also have to think about disability, so limited mobility, grip strength, or reach ranges. And we have some examples like wheelchair accessible counters or specialized tools, those sorts of things. Range of sizes is a selection of sizes a product is made in that caters for the majority of the market. And of course, we're looking at some different size shoes here, and you can see that these are made for a different range of the population. We have to think of clearance, and clearance is the physical space between two objects. And so this is an example of clearance. So we want to be able to make it so that the chair here can be pulled back enough so that the person can easily stand up or sit down. We have to think of reach. Reach is the range that a person can stretch to touch or grasp an object from a specified position. And you can see this is an example of reach. You've got a neutral zone, a maximum reach zone, an extended reach zone. And we want to think about those things when we're in design phases. How is reach important in those scenarios? We have work envelope, a 3D space that is typically physical or virtual that needs to be defined with permissible boundaries of movement and operations. And so this is a work envelope. It looks a lot like the reach diagram because they're closely related. But you can also see this. This is all about the work envelope. Is this person able to correctly sit with their arms at a 90-degree angle, their legs at a 90-degree angle? Is the height of this at the right place? Is the distance correct this way? Is the seat correct? All of these things are going to have an effect. And this is a work envelope. These two diagrams are essentially two views of a work envelope. Another way that we might consider when we're designing is adjustability. So this is the ability of a product to be changed in size, commonly used to increase the range of percentiles for which a product is appropriate. This is an example of a desk that you can move up and down, so it's adjustable. This chair is also adjustable. The tightness of this person's shoes is adjustable. If this person is wearing a belt, that would be adjustable. You can see this is another example. These are inline skates from Decathlon, and they're adjustable. They actually will grow with a child. So this tongue right here actually will make it so that the toe can be expanded or contracted depending on the size of the child. So these are adjustable skates right here. And they're also adjustable here. They can be tightened or loosened right here to accommodate for different sized people. So some design considerations we want to think about is easy reach. So we want to measure things like arm length and shoulder height. And we want to think about the smallest user, the 95th percentile. We want clearance. So this is shoulder or hip. This is width or thigh length. And in this case, we're thinking about the largest user, which is 95th percentile. We want a good match to the product. So this would be, say, for instance, knee to floor height, head circumference, weight. And this, we might think about the maximum range of the 5th to the 95th percentile. That would be more of an adjustable kind of thing. And if we're thinking, for instance, knee to floor height on a chair, is the chair adjustable? Can be moved up and down. If you think of a baseball cap with head circumference, can I adjust the baseball cap so that it will fit a lot of different people? We're going to think about things like comfort and safe posture. So we want to think about elbow height, sitting eye height, sitting and standing elbow height. And again, we want to think of a maximum range in this case. We want easy operations, so we are going to think about, for instance, grip strength or hand width or height. And in this case, we want the weakest or smallest user, and we're going to be thinking about the 5th percentile in this case. If something cannot be reached, operated by mistake, we want to keep a finger's width or arm length. We want the smaller user or 5th percentile, or possibly the larger user or the 95th percentile. All right, thank you for watching.